So today we're on 6-4, day 1, and we'll have 2 days on 6-4. Okay. Our learning target for today is to find and verify inverse functions. So let's start by defining, we're going to start with an inverse relation. This is a relation that interchanges the input and output values. Of the original relation. And let me remind you that your input values are usually your x's and your output values are your y values. So now I'm going to go to inverse function. This is a function where both the original relation and the inverse relation are functions. We've talked about in earlier chapters what makes a function, and so this should be functions. So sometimes you can have an equation that's actually not a function. So if you have an inverse function, both the original and the inverse are functions. Okay, so this isn't bad at all. The first thing we're going to do is learn how to find the inverse function. So, for example, if you started with the linear function 7x minus 4. To find your inverse, the first thing you're going to do is you're going to switch x and y. And the reason why you do this is because of the definition where it said the relation, an inverse is where the input and the output values are interchanged or switched. Okay, so we have a reason for doing this. So I switched the places for the x and the y. And then on the second step, you're going to solve for y. Solve that new equation for y. Okay, so I'm going to solve this for y, so I'm going to add over the 4. And then I'm going to divide everything by 7. And clean this up, pulling out the 1/7. Alright, So now this is actually the inverse function. Okay, so that wasn't bad. Now sometimes you start your problem with f of x instead of y. So then the first step here then will be to change the f of x to the y. Okay, and so then after you do that, then you're going to switch x and y, and then you're going to solve for y. Now, if you use f of x, the inverse is written like this with the little -1 there, and that means the inverse of f. It's not a math operation at all, it's just a definition. It means the inverse of f. Okay, so if you see that notation, that's what it means. Alright, so now we're going to do another topic here. Sometimes a problem will ask you to verify whether it's an inverse or not. So if you have two functions that are inverses of each other, make that S, inverse functions. So if f and g are inverse functions, then something should happen when you do the composite functions that we did yesterday. Then, if I take g and plug it into f, everything will reduce out algebraically and I just end up with x. And if I reverse the order and plug f into g, the same thing will happen. So if a problem asks you to verify that two functions are inverses, you want to do the composite function and show that it equals x. So for another example, let's go back to the original function we had in example 1, and then we found the inverse function, and we found it to be 1/7 x plus 4/7. So if I want to verify that these functions are inverses, I need to do the composite functions. So what I need to do is plug in the inverse inside the original and show that it equals x. So if I plug in the inverse function, sorry, that's a 7, this is what it will look like. So I'd have my 7, and then instead of the x here, I need to put this in. Remember how we did our composite functions yesterday? And then I still need to subtract the 4 at the end. When I multiply through by the 7, 7 times 1/7 is just x. 7 times 4/7 is 4, and then I need to still subtract out the 4, so I just have x left. You don't have to do it both directions, but I'm going to show you both directions. So what if I plug in the original function inside the inverse now? You can do it either way, and it'll come out to be x. Okay? So on my inverse, I have a 1/7, and then I'm going to plug in my original function, and then I still need to add the 4/7. Okay? Doing the distributive property again, 1/7 times 7 is x. 1/7 times -4 is -4/7, and I still add the 4/7 at the end, So again, it just comes out to be x. So today, you're going to have to practice your composite function again to show that two functions are inverses.